Okay, so this is a small little integration that I had written for the board, and let's hope the Wi-Fi works really well on the board. So what we're going to do is include the bridging library, and Tambu, basically the bridging library, is going to create this nice little language bridge for us. We compile down to C code, run everything. Since we have LEDs, now this is where audience participation mode comes in. For this example, we want to use red or green. Who goes for red? All right, green? Woo! All right, green it is. This is the lamest. I swear I had nice little servo motors all ready to go, and okay, so what we're going to picture is this light's going to go off, and picture like going off all around you, unicorns flashing, and rainbows in the sky. It's great. And the servo motors, when we get into those, picture those spinning around, glitter, and glitter going off, and it's just awesome. All right, so we have a pin. There's a long one and a short one. We connect the long pin into digital pin 13, and the short one into the ground. Now, obviously, if you connect this into, let's say, a breadboard to do more extensive hardware implementations, you can plug this in anywhere, but essentially it's long for the actual digital integration, and then the short one for the ground. So we're just going to plug this in and make this easy on us. So what the code is actually doing in the LED, we're setting the pin, the digital pin that we're going to use to control the LED to pin 13. This can be any of the pins in that line from 1 to 13. Then on the setup, we are setting the pin mode that we should be communicating with for the board. We're going to begin the serial monitor. The serial monitor is going to actually be how we debug. Think of it like the developer tools on Chrome. It's pretty much the same. It can output data. And then we're just going to start the bridge and set up some debugging information. Now the loop in the program is actually where the program will loop over and over and over again. But we can control it with any different methods that we want to set up. But in this integration, first we're doing a serial print line, same thing as a console log. It's just printing out the serial. We can print out any information that we want. We set up using Tambu, what they call a choreo, and a choreo is a wrapper on top of the API. So think of it just like every single API endpoint has a different little wrapper around it, and that's called a choreo. We begin the choreo, then we set up the account information for it, and the account information was referenced up here in this header file, tambu-account.h. So we're going in the .h file, we just have some definitions for the particular accounts, the app, and the app key. So that's how you work with Tambu. And then, when we're working with PayPal integration, doing a direct connection, and this can be any API, it's just really setting the variables that you want to push through for the API endpoint. So we're doing client ID and client secret. That's OAuth 2 credentials in the PayPal world for the REST APIs. Set your cancel and return URLs for the actual payment going through. Your currency is USD, and your total for the amount being paid is $5. So we're going to run a PayPal payment through that thing. Then all you need to do is set the choreo endpoint. This is basically the library that you need to set up. When you're actually going to Tambu and take a look at their libraries, all this information is provided on which ones to particularly use. You're going to run the choreo, and then once the choreo runs, you can monitor the serial output. So the serial output is going to be what's spit back from the API. And realistically, in this particular integration, it's going to be a JSON result. So you're going to get a JSON payload being sent back. So what we're doing is reading in character by character from that output and spitting it out to the serial. And then we're going to close the choreo and just flash the LED. All right. Are we ready to see if this works? All right. We have program. Upload program to board. And then the program down here is showing it's uploading. It's setting up. And we're done. Now let's see if this will work properly through the MiFi. Load up the serial monitor, and what we should be seeing is, in a moment, it's starting up, running the accept PayPal payment, and JSON results. We just made a PayPal payment through a MiFi, pushing to the LED. So that's So that's the really cool part. You can basically do this on any API endpoint you want. It's really handy to work through. I love the integrations that are on this. But we can make this easier, much easier. Now you see the pain points that you're going through. Who here works with C on a regular basis? Exactly. One. So that's why we're going to start working with JavaScript and Node. It's going to make it much easier for us. So let's start taking a look. Let me zoom out a little bit into JavaScript and Node through the Arduino devices themselves, because this is where we all want to work. But before I get into working with the Arduino, there is one other really cool board that I want to mention. It's called the Tessel. The Tessel is due to launch in June. If you go to tessel.io, you can actually see it. And what it is a microcontroller board like an Arduino that's run completely through JavaScript. So everything you program out of the box is run through JavaScript. And these little black bits on the top and bottom and on the far right side, these are actual ports for integrating different type of boards. So instead of sandwiching the boards together, instead they built little extension boards that you can add in. So let's say you have a moisture sensor that you want to add in. You just plug it in into one of those little ports. If you want to add in a human sensor, you add it to one of those ports. And you can just control it through JavaScript very, very easily out of the box. So you don't have to work with bridging libraries to convert your language down to machine code. It does it automatically throughout the board. So I just figured I'd mention that one. I have some of these on order to play with because they're really interesting boards and a really great way to start working with microcontrollers. Now, if you're working with the Arduino side and working with these boards, there's this really cool library out there called Johnny 5. How many of you remember this movie? Yes. And that tells me I'm not quite that old yet. When I go to universities, we're like, what the hell is this? Yeah, that makes me depressed. But anyways, Johnny 5 is a really nice bridging library that allows you to work directly with a Arduino device, programming Node on your laptop, pushing through to the device, and converting that to machine code. The way that it actually does this is through a communication network. You start with your Node script, and utilizing the Johnny 5 framework, you're basically going to be writing in Node JS to control the LED outputs or the servo controllers or any other motors that you can think of. You can run everything off the board and control it through the framework. So you write your script out. It communicates through a technology that you upload to the board called Fermata, so standard Fermata. We'll get into that in a minute on what that is. Standard Fermata works as a bridging library for the language. It takes the Node.js, converts it on the board to machine code, and then allows that to control the microcontroller. Kind of cool little device. But the good thing is that Fermata is actually an open standard. What it allows you to do is basically take any sort of language that you might want, and using Fermata, it can convert it directly to the machine code. So if I want to work in PHP, Python, Go, anything any language I might want to work with, it can convert it in because it's a standard machine language working module. So that's one of the really good things. Now, how you actually push this on the board is really nice and easy. So you're just going to go to File, Examples, Fermata, and select Standard Fermata. Now let's look at this in just quick detail in the actual Arduino IDE. So if I am going to File, Examples, do Fermata, Standard Fermata, it's going to load up just the standard example that's out there. We do not have to touch anything. We don't have to edit any of this code here. All we need to do is push it up to the board. So it's loading right now. The LED is going off, showing that it's loading the digital pins, and everything's right, and it's done. And that's it. That's all you need for the bridging library between some external language running on your computer towards the Arduino. Easy so far, right? Next, we start working with Johnny 5. So it's really complicated to install Johnny 5. You have to run this whole command from Node. So npm install Johnny 5, and then you get the Johnny 5 package installed directly within your Node integration. So you have Node, you have Johnny 5, you're ready to go. can't believe how hard this thing is. Okay, then the first code that you're going to write in your Node.js script is really just these 1, 2, 3, 4, 5 lines of code. So the 5 lines of code are essentially enabling Johnny 5 and plugging in Johnny 5 to reach the board that we're going to be working with. So you set to a couple of variables. The first one, 5, is the reference to Johnny 5, so the Johnny 5 capabilities for leveraging off of the digital pins or the LEDs or servo controllers or anything like that. Then you reference the actual board, set a variable to the board, so it's new Johnny 5 board. Then on ready, when the board actually is ready to go, so it's all booted up and it's ready to accept commands, that's where you would run your code. That's where you would actually run all your LED or whatever connections. So if we want to do an LED, now these are they're really the think of these like the hello world of the hardware microcontroller integrations. The first program that everyone usually writes is hooking in an LED and flashing it. So the way that you actually work with this is when the board's ready, all you need to do is say new 5, which references Johnny5.led, set the pin that the LED is actually on, so 13 or whatever it might be, and then you set it to strobe, so it's basically a strobe is turning the light on and off, so high mode to low mode, and do that every 3 seconds. So the pin or the LED pin should flash every 3 seconds, on then off. Let's say you wanted to access a servo motor. Now this is where the servo motor would be kind of cool, shooting glitter all over the audience. It's probably good that it didn't happen. But anyways, this is how you control a servo motor. So the servo motor would be like a little motor controller with a little arm on top. And the arm on top can swivel. So what you can do is hook that up to wheels, or you could hook it up to the little droppers. Now what we were going to do with servo motors was create the what we call the swaginator. Now the swaginator was a way for us to replace ourselves at booths. So we set up the swaginator and someone goes and scans their badge, and using the servo motors it determines if they're an actual person, if they've got swag before, and then the servo motor controls a little dropper which drops the swag out to them. The swaginator. My wife came up with that one. And then I stole it and told the team, and then she hit me for stealing her idea. Alright, but anyways, working with the servo motor is really easy. You work in degrees. So we just say servo new 5.servo, setting up a new Johnny 5 reference to the servo, setting it to pin mode 10. So the servos themselves, let me disconnect this LED. You have all your digital pins over here. You have a power ground, your 5 volt over here. So 5 volts would typically run electronics like this. So you have 3 wires coming out of a servo motor. You have one for power, one for ground, and one for control, which is to the digital pin. You connect the power to 5 volts. You connect the ground to ground. And then you connect your controller to whatever digital pin you want over here. So in this case, it's 10, or it would be 10. Then you can do commands like servo.to 90 degrees. It will swivel the servo arm to 90 degrees. And then we can wait just so it finishes the actual turn. And then we can call other commands like servo.sweep, which will sweep the arm from the min to max, which is 0 degrees to 180. So it's going to go back and forth, just one rotation. We can also do things like servo.min to go to 0 degrees by default, servo.max to go to 180 if we want. We can do something like servo.center, which will push it to a 90-degree angle. Or we can just throw in a JSON object to the servo controller to do something smarter. So you can extend this quite a bit on the actual control. Alright, so let's see how this is actually going to work. Let me load up my terminal window. Now, we're going to use red for this one. Oh man, it's going to be awesome demo. Remember, long pin to 13, short pin to ground. Okay. Terminal window is up, and I have a program already written. So what we're going to do is load up strobe. And we're just really leveraging off these 2 little pieces of code that we saw before. We have the Johnny 5 board, new 5 board, and when the board's ready, we create a servo controller. We serve it to 90 degrees, and then we do a full sweep. And then we set off the strobe every 3 seconds. So this is actually how you're going to work with it. I have this JavaScript or this Node file that's ready. And it's connected right here to the board. So now we're going to just run that. It's going to connect to the board, go to standard Formata. Standard Formata will convert the Node.js to machine code, then run this. So what we should see is the LED come off. So it's connecting. Then what it should be is it should go to initializing, and with any luck, there goes the light. That's how easy it is to work with JavaScript and Node.js directly to the board. Now I'm going to turn this thing off once it goes, and now the board is set up and done. So basically, once you want to run this program, you can just run the Node script and it'll just push directly through. So really nothing complicated, right? Yeah. That's what I love about it. We have abstraction layers that allow us to work with the languages that we want as opposed to the languages we're forced to on the board, which is how it should be. Now, beyond Johnny 5, which is the one I like, it's, think of it like the same as less versus SAS in the CSS world. Everyone has their favorites. There's also this other project, open source project out there called Arduino. And Arduino allows you to work more with web applications. So think of it this way. Through Arduino, you would be connecting through a web application. So let's say a user comes to your web app and clicks the select button. Select button can be tied to a particular event mode that pushes to the board and sets off an LED, or you can use it to shoot people with a Nerf gun in call centers. Those are always fun. But you have to make sure you have security so that someone doesn't go in and hack and shoot them. But that's a really good integration, and it works with a kind of a variation on the Formata example that we saw. So what you need to do in order to get this working is you download Arduino, and you can just download it from the GitHub repository here. Then you take what they call a Arduino file. It'll just be available in that repository, and push that up to the board as opposed to this standard Formata example. That's their transfer bridge that they built out. So that's really all it is, and then you can start working with this implementation, which is slightly different than Johnny 5, but really easy as well. It'll all make sense when you go through all that and you see all the different ways, like connecting to the LED. It's really less versus SAS. It's the same type of thing. You work with one, you can switch to the other with very minimal changes. All right, so finally before we end, where are we heading with all these microcontrollers and hardware? It's cool for prototyping, but realistically, what's happening here? Well, we've seen a huge, massive improvement in the maker community over the past couple of years. With the invention of these devices and small little open microcontrollers in the open source world, people are finally able to start controlling the world around them. And now with bridging libraries for any particular language, like Arduino and Johnny 5, or for any particular language, they have a bridging library out there. This allows us not to have to force ourselves to work within the C world or work within the language that's restricted on the board, and go towards the languages that we're all working with on a daily basis. So the onus for us to actually start working with hardware and start improving the world around us has changed so significantly, so that we can really start building in components to do everything from security to biometrics to just simple little hacks that improve our world. That's what this is all about. This complete revolution in the world through microcontrollers and the maker community is going to improve our lives so significantly in the same way the internet changed the world. So thank you very much, everyone. My slides are up on this link if you want to download any of the examples. I appreciate you all coming.
Just so we're really close on time, if Jonathan wants to do a couple questions, you might just slide them up here.
Sure, sounds good.
The other guy.
Okay.
We probably do a couple questions, but then we want to get everyone, if you're heading off to another area, get you enough time to head off to your other areas. We basically pushed everything back 20 minutes, so we're just going to cut into lunch a little bit after this next round of talks. So did anyone have questions? Yeah,
okay, sounds good. I'll set up over here. So as I'm shutting down, what was
if you had not yet gotten started, would you wait for the Tesla or would you go ahead with Arduino?
I wouldn't wait for the Tesla, because the Tesla is really cool to work with if you're into JavaScript, but it's one board. You can control so many. Sorry about that. You can control so many different boards with an Arduino, and I would particularly start working with those boards instead. Get started with an Uno or a Yun. Best